Hey, it's Greg Getter. I'm starting a new project, which is going to be about building a smart speaker using some of the latest technology. So think about devices like the Amazon Echo or the Google Home. This idea has been around for about 10 years now. And in those last 10 years, we've really seen the idea of ambient computing take off in a way where the Echo and Google Home are in many people's homes. But we've also seen some limitations of technology, of the user interfaces, of the inability to interact with these devices in a truly natural way. And ultimately, what ends up happening is people end up using these devices for very limited tasks, like maybe getting the weather or playing a certain track on Spotify, or maybe turning on and off certain lights. And it's not really the ambient computing experience that people had truly imagined. But there's a new technology that came out recently from OpenAI, which is called the Realtime API. It's a conversational interface that you can add to your own applications and devices. And I think that combining this idea of an LLM with a real-time speech-to-speech API with a hardware device that's vaguely like the Amazon Echo or the Google Home would actually get us to the point where we have a much more interactive, much more useful and conversational home assistant. So I'm starting this new video series where I'm going to take you through the considerations and how I would actually build one of these devices with the goal of actually building it and getting it to the point where it's an open source project so that you could build yourself. I'm going to start by outlining some of the specifics and challenges of the current state of the art with smart speakers, as well as walking you through the OpenAI real-time API today. And then in subsequent videos in the series, I hope to walk you through the hardware, getting the software set up, adding different functionality to it, and ultimately building it into a pretty usable product. Now, I was inspired for this project by something called the DIY Sun, another video series that's here on YouTube, where the creator actually tried to duplicate the Dyson Light Cycle, Solar Cycle, CSYS series of lamps by building his own lamp from scratch and without ever having one of his own. I think that it's my idea here to build a smart speaker using this new real-time API technology, um, inspired by those devices like the Echo and the Google Home, but trying to eliminate some of the disadvantages of those. So I want to get into the disadvantages of those devices now, and then I'll talk about how this new real-time API is going to be better than the existing approach for conversational ambient computing. Let's do that right now. So, as much as I love the concept of these devices like the Echo and the Google Home, I think that there are some key limitations that are really holding them back from reaching their true potential. The first is that the conversations you have with these devices tend to be quite limited and unnatural. Now, I think that these devices do actually understand pretty much everything you tell them, but the actions that they're able to take are quite limited, and the interaction is quite robotic. You have to speak to it in a very particular way instead of just speaking to it in a more natural way. And that leads me to the second point, which is the skills that are available in a platform like Alexa. So skills, if you don't know, are like apps that you would find on your iPhone, but for your Echo devices. And these skills allow you to go get specific information or play games, or interact with certain platforms like Spotify, for instance. And the problem with these skills is that the UI is invisible. So on your phone, you have visual indicators, the icons that allow you to call up the apps. But on your Echo device, for instance, you actually have to remember the name of the skill and remember the very specific set of commands that are available to you to be able to successfully execute that. And that just becomes very limiting instead of just asking it what you want and expecting it to figure out what you want it to do for you. The Echo is not really able to do that at this point in time. And I think that that's a huge limitation. So the solution to this problem of limited contextual understanding or the inability for it to act on an arbitrary input is including a large language model instead of the older way of approaching the contextual understanding that they're using in a device like the Echo. So I think what's really potentially useful here is the new API that OpenAI just released a month ago on October 1st, 2024, which they call the Realtime API. And this API is an LLM. I believe it's GPT 4.0, but it enables you to interact in a natural way. So the main advantages here are that it's a low latency speech to speech API coupled with a LLM. I'll break down how all of this works in a minute, but the benefit here is that it's fast enough to feel like you're conversing with a real human instead of having to figure out exactly what you want to say to be able to get the device to execute your command. Now, if you've been playing around with ChatGPT and you've had a chance to try the advanced voice mode that's available on this app, this is essentially the same idea. But now you can bring that same advanced voice functionality to your own apps and devices using the real-time API. The other big benefit of this API is that it's stateful, which means that it remembers what you said in a given section. This is an improvement over a number of LLM APIs where you have to keep passing in your previous conversation history if you want it to remember what you said before. You don't need to do this with the real-time API. You just start a thread and it will remember the context of what you've said before so it can continue that conversation in a very natural way. I think it's going to be worth it to judge this platform by jumping into a quick demo so I can show you and explain what's going on in a little bit more detail. So I'm here in the real-time playground, which can be found at platform.openai.com. You create an account or you log in, and then you can click on the playground and then real time on the left side. And this allows you to play around with the parameters, things like the system prompt and some of the settings for the real-time API and test it out in your browser without having to write any code. So it's really useful for getting a feel for how this thing might work before you get deep into your coding project. And a couple areas that I want to pay attention to. The first is the system instructions. So normally when you create a prompt for an AI assistant, you give it some information about how it's supposed to behave and act. So this is the default set of system instructions here. You're a helpful, witty, and friendly AI. Act like a human, but remember that you aren't a human and that you can't do things in the real world, etc. We also have the ability to adjust the voice activity detection, where it can detect the turns that I am taking versus the API speaking back to me. And then I'll get into some of the other parameters later. So I'm going to go with just this default set of system instructions to show you what the real-time API looks like and how it works. So I'll click here in Start Session. Hey there, how's it going?
Hey, I'm doing great. Thanks for asking. How about you?
Yeah, I'm all right. I'm trying to record this video right now, and there are actually jackhammers outside, so I'm worried that the sound is going to pick up. But we'll hope for the best.
Oh man, that's always tricky. Those background noises have a knack for showing up at the worst times, huh? Hopefully, your microphone has good noise cancellation. Fingers
Yeah, I'm
crossed
trying
for
to
a.
make a video about voice assistants. Basically, I want to build a better version of Alexa. Do you have any tips for me?
That sounds like an exciting project. Here are a few tips for building a better voice assistant. 1. Natural language understanding. Prioritize understanding the user's intent, not just their words.
Okay, so I think you can see within this demo some of the key things about the real-time API. The first is that it responds very quickly. It's almost like I'm having a conversation with a real person. And you might have noticed that I actually interrupted it and cut it off before it finished speaking. It stopped speaking and listened to my new prompt. And you also might notice that it acts a lot like ChatGPT, where it's spitting out answers, lists of an answer, but it's doing it over voice instead of text. Okay, so that was a pretty good first pass. And what I want to do now is show you some of the parameters that I just changed. So I changed my system prompt here to you're a smart speaker like the Echo or Google Home. You can answer questions about the weather, make up information if you don't know. And I also asked it to make its responses funny. And I also shifted one of the parameters down here called temperature. Temperature in LLMs basically allows you to adjust the trade-off between accuracy and creativeness in your answers. So a lower temperature, something closer to zero point 0.0, would give you a more accurate, less creative answer, and theoretically a more consistent answer every time. Whereas a higher temperature, maybe around 1, as I have here, would give you something a little bit more creative, maybe a little bit funnier even, since I told it to be funny. I did also change the voice to echo. You can see that there are a number of voices here within the Realtime API. So I'm going to give this all a shot now and see how it pans out. Hey, how's it going?
I'm doing great. Thanks for asking. How about you? Hope your day is as
Yeah, I'm trying
smooth
to
as a
film a video right now, but I've literally got jackhammers and sirens in the background. I hope the best for those people, and I understand the problems, but I wish that it was a little bit quieter to film this video.
the classic soundtrack of urban life, right? Jackhammers and sirens make for a great industrial theme, but they're not the best for your video's audio quality. Maybe you can tell everyone you're going for an avant-garde vibe, or
Yeah, that's
perhaps,
true. That's true. I'm actually wondering, do you know what the weather in San Francisco is going to be later today?
oh, San Francisco, the city of unpredictable weather. Later today, you can expect it to be mostly mild, with a high chance of some fog rolling in. Because it's San Francisco and the fog likes to make a daily appearance like a dramatic actor on stage. Don't forget your light jacket. It's practically a part of the San Fran dress code.
Yeah, that's true. Whenever I go out and I don't wear layers, I instantly regret it.
Yep, in San Francisco, layers are basically your best friend. Going out without layers is like challenging the city's microclimates to a duel. One moment you're basking in the sun, the next, the fog swoops in, and bam, you're shivering like you've just seen the bill after a fancy dinner. Stay cozy out there.
So that's pretty cool. We got to try out the different voice. It got to be a little bit more clever in its responses with the higher temperature and the new prompt. So I think you can see that this is a pretty conversational AI, and it brings a lot of the possibilities to a home speaker assistant that you wouldn't have had in the past, where you had to give it very specific, clear directions to get it to do what you want. This is much more conversational. I think it's going to be instructive to break down the approach that's used by something like Alexa versus what the speech to speech API does from OpenAI. So the traditional approach is essentially going to follow this pipeline of taking spoken language as an input and generating speech as an output. And in between, there are really three categories of steps. The first is automatic speech recognition. The second is natural language understanding. And the third is text to speech or speech synthesis. And within those three steps, you can really break it down to a number of sub-steps. So within automatic speech recognition, for example, you have features like taking the audio input, running some signal processing on it to improve the quality, extracting different features from the input, and decoding that input into text. Then within the step of natural language understanding, you have things like intent recognition, entity recognition, context analysis, and then ultimately you are generating text. And then finally, once you've generated that text output, you are using text to speech to generate that speech. So this traditional approach uses really this three-step pipeline of automatic speech recognition to natural language understanding to text to speech. And a number of people have built pipelines that kind of take the automatic speech recognition and the text to speech, but instead of having these traditional machine learning approaches in the middle, they're using LLMs so that the conversation becomes more natural. Now, the issue here with Alexa, at least, is they don't currently seem to be using things like transformers for language understanding. So you have to speak to it in pretty robotic way. But if you were to sub out that traditional ML approach to something like transformers or large language models, then things might start to feel more natural. And indeed, it sounds like Amazon is actually working on adding an LLM to Alexa to make it more conversational, but that doesn't seem to be released yet. It's also definitely possible to build this type of pipeline on your own with an LLM in the middle, but there is one problem with using an API like the OpenAI API or Anthropic API with a model like GPT-4o or Haiku. And the problem here is that even though you have the much better conversational ability, you still struggle with the latency because each of these steps has latency of taking that speech and turning it into text, of coming up with an answer and then generating that speech output. And in that way, it's still not truly as conversational as you could get it to be. Now, with the real-time API, which you might also call a speech-to-speech API, the key difference is that it eliminates that intermediary text transcription. So when you have the automatic speech recognition, it doesn't necessarily take the data and turn it into text first. And then once you have the response, it doesn't necessarily do the text to speech. It's more of a direct speech to speech API that's much lower in latency. And this allows the interaction to feel much more conversational. So there are a few key components to making all of this work. So the first is that you have the session or a WebSocket or WebRTC connection between the client and server. And you're going to need this session to generate the connection between the client and server because it's not a RESTful API. It actually has to operate with streaming audio in this instance. So what you do is you take your input audio buffer. So that's me speaking into the device. And you're going to use that input audio buffer to start interacting with the API in real time through that WebSockets connection. Then we have something called voice activity detection, which is when we're going to detect whether the user is speaking or not. So basically, it detects when you start speaking and when you stop speaking, then it tells the API that it's time to generate a response. This voice activity detection can also detect interruptions. So if you want to speak to it before it's finished speaking, the voice activity detection can say, hey, stop generating the speech now. I want to listen to the user again. Then you have something in the speech to speech API, which is the conversation, which stores the state of both the user and the assistant messages. So this is why the API is stateless, because it's actually storing this message history so it can look back on that and add it to the context. And then in terms of your output, you actually get both the text and the audio output. And I'll explain why this is useful in a minute. But the speech to speech API is going to generate text and audio at the same time. So there are a couple interesting things to note about this real-time API. And the first is that the output is faster than real-time. What this means is that the response text and audio chunks are generated faster than they can be spoken. So essentially, if you were to play back the audio as fast as it was generated, it would actually be speaking over itself. It would be speaking multiple words at the same time because it can generate those audio sequences faster than they can be spoken. So what you need to do is you need to put the audio in a buffer. You don't want to play multiple words at the same time. But this opens up a very interesting possibility, coupled with the fact that both text and audio are generated by the real-time API. And that is if you want to put guardrails on the output. Guardrails are essentially having an LLM or some other system check that the real-time API is not generating content that you don't want it to say. So, for instance, you might not want it to talk about adult content, or you might not want it to talk about a competitor if you were going to turn this into a real production product. So the guardrails could actually check the output of the real-time API by looking at the text. And then the guardrails can basically have a true or false signal to say, hey, this content is safe, or hey, this content is unsafe. And if the content is not up to the content standard, you can actually take the audio output buffer and mute or clear it. This is just one way to approach this. There are many ways to deal with guardrails and your LLM, but I think that this is just a simple example of using both the text output to moderate your output, as well as generating the audio output into a buffer. The other thing that's interesting here is that you are able to interrupt the model, and that is essentially because it's generating the response so fast. So essentially, when you interrupt the model, your voice activity detection is detecting that you're speaking again. And you can use that same idea to say, hey, clear the output buffer or mute it so that the user can speak again and we can respond to the new information that they've sent in. The real-time API is really great in that it enables realistic conversation, but it's not going to be very useful in a smart home system if it can't do things like controlling the lights or getting the current weather. So I want to touch on a feature of many LLMs that's going to solve this problem for us, which is called function calling. Function calling allows you to make data available from other systems or to execute actions on other systems by providing something called tools that your model can interact with. A basic example would be checking the weather. So the real-time API doesn't actually know what the current weather is. It's just able to generate these text sequences for you. So if you use the real-time API raw without providing the weather tool, it will either tell you it doesn't know the weather or it will just make up a response. But if you provide a function like get weather, it will actually tell you when it needs the weather, and you can go fetch the weather from an external source and provide it back to the model so it can keep interacting with the user. The real-time API can't actually execute this code for you. It just generates the function call. So if I ask, what's the weather in San Francisco? It will actually generate the function call, get weather San Francisco. But then I have to write the code that actually goes and fetches that information from something like weather.com and then pulls that information back into the real-time API. Then once the tool response is provided, the API will respond in a natural language way. So by combining the features of the speech-to-speech real-time API with the function calling, you're going to be able to provide real information that's usable to the user. So let's try this out in the real-time playground. I'm back here in the real-time playground, and what I wanted to do now is show you how function calling works. So I'm going to go to this section, functions, and click add. And I'll use this really handy generate feature to generate two functions. So the first one I want to generate is getting the current weather. So OpenAI will go generate this function, which it has decided to call get current weather. And it takes in a couple of parameters. The first is the location. I think that's very important. The second is the unit. So Celsius or Fahrenheit or metric or imperial in this case. And then the third is the language of the response. So I'm also going to click this checkbox for respond with automatically generated output. In your actual production use case, when the API makes a function call, you have to write the script and on your own server or device, actually go out, make the request to get that information and provide it back to the API. But for continuity's sake, so you can see how this would work in practice, I'm going to have OpenAI automatically generate a response here so that you can feel what it's like. So we have one new tool call available here, get current weather, and I'm going to add one more, get the weather forecast for a particular location. So we got this new function, get weather forecast, and it has a few properties. So the first is location, and the second is going to be date. The third is units, metric or imperial, and the fourth is a forecast type. When you create your own functions, you can certainly customize these, write them from scratch even. They don't necessarily have to have this many parameters, but we'll just go with what OpenAI suggests here for ease. So I'm going to save that. And now we have two tools available to be called. I also edited the prompt here and I removed the bit about making up the weather response. So what I'm going to do now is I'm going to start my session and show how the tool calls would work in practice. Hey, what's the weather right now in San Francisco?
It's currently 68 degrees Fahrenheit, then partly cloudy in San Francisco. The humidity is at 72%, so your hair might be doing its own interpretive dance right
Gotcha.
now.
Do you think it's better for me to bring a sweater or a jacket with me?
Given that it's 68 degrees Fahrenheit and partly cloudy, I'd say a sweater should do the trick. But if you tend to be on the chilly side, or plan on staying out after the sun sets, a jacket might be a safer bet.
Hey, so
Plus,
I'm also going to New York City this weekend. Can you tell me what the weather there is going to be like on Sunday? I'm wondering if I need to bring a heavy jacket or not.
on Sunday in New York City, you can expect a high of 55 degrees Fahrenheit and a low of 41 degrees Fahrenheit, with partly cloudy skies. There's a small
Ooh, that's
10%
going to be
chance of
pretty
precipitation.
cold. I definitely want to bring a jacket and a sweater in that case.
Great idea. You can layer up with the sweater and then add the
Okay, so we can see the function calls were generated. The first one was getting the current weather, and it generated a response. But this is where we would actually write in code to go request from an API like the weather.com API, and then provide that information back to the model. And you can also see we had our tool call get weather forecast. It called the weather forecast for a particular date in the future, and it responded with some information about what the weather is going to be like. And then the model interpreted that information with information about whether I should bring a heavy jacket or a sweater. So function calling is quite a useful feature, and I'd say it's actually totally necessary for the purpose of building a smart speaker, because otherwise it's just going to be something that you can talk to and it's not going to be very useful. So getting the current weather and getting the forecast are examples of two tools that we could bring in to start to bring this device up to parity with something like the Echo. And here are some other tool ideas that we might build to make this project more usable. We might be able to make a tool call to an internal clock and timer so that we can set timers and set alarms. We might be able to trigger an external system like Home Assistant to adjust our lighting. We might be able to work with a music streaming service like Spotify to start playing music. We might use a simple RAG approach to maintain a grocery list or a to-do list. These are all examples of possibilities that we'll explore in future videos in this series once we've started to lay the groundwork for implementing the real-time API on our device. Adding these tools is going to really enhance the functionality here. None of this is to say that the real-time API from OpenAI is perfect. Number one, OpenAI only makes its models available either via ChatGPT or via cloud APIs. And there's no way to make this run locally on your device. You're going to have a stable internet connection to make this work well. With that said, you probably also need a much more powerful device to run this, which could get quite expensive. We're trying to target a device that's in the sub $100 category. So we would need to rely on external processing in this instance. Now, compared to other generative AI APIs, the OpenAI real-time API is quite expensive at $100 per million input tokens and $200 per million output tokens. That translates in the real world to about 6 cents per minute on the input and 24 cents per minute on the output. So it's not very cheap, especially compared to text-based LLM APIs and maybe some self-hosted things. But I do think that this speech-to-speech API represents the next generation, and we do want to build this proof of concept using the latest technology that we have available. As with other APIs from OpenAI, I expect the price of this to come down over time, but it's not prohibitively expensive to start building as a proof of concept. just keep in mind that this project is going to have an ongoing cost to keep using it beyond just purchasing the hardware and getting the code working. If this proof of concept works out in the future, we can investigate some other options for speech to speech that don't have these limitations, like having to call an external cloud API or the high cost. But let's just get it working with this and then we'll go from there. I wanted to walk through some of the hardware considerations I have for this project. I do want it to be in the form factor of a small hardware speaker like the Echo Dot or Google Home Mini, for instance. So I do want to build some hardware that is roughly the size of that and has its own built-in speaker and microphones. So right now, what we're focusing on, I want to pick a hardware platform, a CPU or a system on a chip that's powerful enough to be able to run WebSockets or WebRTC and is powerful enough to run Python or JavaScript code. Now, one of the devices I stumbled upon in my research for this project was called the Atom Echo, and it actually has everything you need to build a smart speaker already built in. So it's essentially an ESP32 system on a chip with a basic speaker and microphone. But the issue with this device that I'm concerned about is that it's based on the ESP32, which I just don't believe is powerful enough to run something like this. I could be wrong, but I wouldn't want to start with such a restricted hardware platform at this point in time. Also, generally speaking, the ESP32 is more of a C and C++ based system. So I think that the code would be more complicated to write for it. And frankly, I just want to get something working in the easiest way possible. So going with something that supports Python and JavaScript and has plenty of overhead to be able to run a real-time streaming application is going to be an asset in this case. So later, we can certainly think about how we optimize the efficiency of this and maybe go with a smaller device. But I wanted to start with something pretty powerful to start. So I ended up ordering a Raspberry Pi 5 with 4 gigs of RAM. Now, I imagine the Pi 5 is overkill, and we're probably going to be able to get away with something cheaper and less powerful like the Pi 2W, for instance. But I just rather not run into hardware related performance issues right now. Let's get everything working. We can monitor the performance and determine what hardware would actually be sufficient for this and what cost at a minimum would be required to work with something like the OpenAI Realtime API, which is a streaming API. Now for sound, I don't think I'm going to have this totally optimized right out of the gate, but the simplest thing that I found for now is something from Adafruit called the Voice Bonnet, which has both a microphone array and it easily lets you connect speakers with a headphone jack or its built-in amplifier. So I bought the Voice Bonnet as well as a 3-watt speaker to go along with it. I'm sure we could cost optimize on this, and I'm sure we could also do a much better sound or microphone array. But I think right now we're going to be more focused on getting the API and function calling working. And then later we can worry about things like the sound quality and the microphone quality. So I ordered all these parts from Adafruit, the Raspberry Pi, the voice bonnet, and the speaker. And I also ordered a micro SD card from Amazon to serve as the storage on the Raspberry Pi. So in one of my upcoming videos, we'll start piecing all of these hardware pieces together and we'll start trying to get the software running on that hardware. I'm also going to get started with the software right away because I haven't gotten a shipping notification for all of the parts yet. So stay tuned for a video. One of the next videos will either be the hardware or some of my early work on the software with the Realtime API. As I mentioned, this is going to be a series of videos. So this is just the first video, and my actual intention is to run a series of several videos where I walk you through building this Echo-like device with the OpenAI Realtime API. So I'd encourage you to subscribe to my channel so you can keep getting updates as I add videos to this series. And also I'd encourage you to leave any comments with any questions or suggestions you have about anything, about the hardware selection, about working with the Realtime API, really any ideas for tool calls. Any of these ideas are going to be super useful for me as I start building out this smart speaker and hopefully build it into an open source project. So I want to say thanks for following along. Please like and subscribe if you haven't already. And I hope you have a great rest of your day.